This is the engineering solution to Coral Castle and its magnetic flywheel. My name is Scott Russell. I was born in 1961 in Burlington, Vermont. Recently, I have been attracted to the mystery that exists surrounding a place called the Coral Castle Museum. This site is located near Miami, Florida, USA. It is currently on the United States National Registry of Historic Places. This magnificent attraction was made by one man named Edward Leedskalnin. Ed was born in Latvia in 1887. His family came from a line of stonemasons, and his grandfather owned a cemetery tombstone monument establishment. Ed Leedskalnin emigrated to the United States around 1912. Here he learned how to rig big logs and worked in North American mines. Eventually, Ed would find his way to warmer, healthier weather in South Florida. He was known to be a smart man, and it is also said that he read a lot. Ed died in 1951 and left us an enduring megalithic site to behold physically here on Earth. But he also wrote 3 quaint, informative, semi-independent booklets that in most cases accurately describes 1. Natural life, 2. Some of his philosophy, and 3. More significantly, magnetic current. One large and very important thing he also left us was a unexplained magnetic iron flywheel assembly that has perplexed non-intellectual and intellectual communities alike. These include the Army Corps of Engineers, college professors, Coral Castle enthusiasts, and common mechanical type lay folks. Due to the permanence of this high-profile unknown apparatus, much controversy and hypothetical conjecture has shrouded its true purpose. In Ed's little book entitled Magnetic Current, he states that he had built 10 of these machines. He uses the word machines. After much research that includes reading, searching files, measuring actual values of factual remains, and conducting actual experimentation, etc., I have deduced the simple logical truths about Coral Castle. I have built one of Ed's machines to almost full completion. Most of this truth behind this machine was hidden due to many unforeseen occurrences and circumstances. Also, significant engineering knowledge and mechanical aptitude is required to actually describe the total process that Ed used, as well as the true purpose for the wheel and its 4 prominent clover leaves from an electrical point of view. To begin, I would like to mention that no one has properly explained in detail the actual coring process Edward Leedskalnin used to cut large coral limestone blocks. Also, might I add that the cutting device he used is still down at the museum today. Let's start with how he quarried. First, one must erect a large tripod. It's not hard, really. The secret is knowing how. This now is how one man can perform this task. First, one needs to retrieve 9 poles, 3 small, 3 medium, and 3 long. The length should be 10, 20, and 35 feet respectively. To briefly overview the concept, realize that a small manually erected tripod will lift bigger unmanageable logs with a hoist. Start by laying the logs on the ground in a 3-way X, Y, with the ends overlapping at the center about 1/15 of the overall length. You then loop the tops together. The chain that encompasses all the logs must have 1 extra diameter of folding slack that will tighten upon lifting and binding. Now, using 4 bolts with locking nuts, Make a separate triplex Y chain configuration that is bolted at its center and bolted, forming 3 loops on each end of the Y spokes on that chain. Notches are cut into the ends of the next set of tripod logs to be lifted. These loops are slid into the notches so that when the feet are pulled together, the logs cannot slide past each other, instead forming a Y-yoke lock on top, thus allowing the poles to rise when pulled from their bottoms altogether. Attach 3 come-alongs to the base of the poles on the ground. 2 can be used in a Y configuration also, but using 3 is safer and gives more independent tripod foot control. Slowly increase tension by hoisting and pulling as you go. When the tripods are at a man's height, attaching a chain hoist to the last chain looping to the top of the tripod will allow the chain hoist to rise with the rest of the unit. In a short time, you can erect a large tripod this way. Once this step is performed, probably a max of 20 feet for stage 2, a third much larger 35 to 40 foot tripod can be erected. It will be done in exactly the same way as stage 1 to stage 2. You will now go from stage 2 to stage 3. You will need to size the chains, hoists, and come-alongs accordingly to the much larger sizes. On the largest and final tripod, a shackle can be pre-assembled on the ground to provide a flat and reliable anchoring point on the top. This will be lifted in the same way just described. Now we will investigate the quarrying technique. Coral limestone can easily be cut with a wood saw by hand. It can also be cut with a machine doing the work. To do this, you need a large cutting edge. At the museum today, there's a giant iron door that has a 16-pointed sun drawn on the face of it. This large iron door was used to cut the blocks. Position the newly erected tripod over the area to be cut and quarried. This is accomplished by using the wheelbarrow-looking apparatus at the museum today. This homemade counterbalanced contraption is actually a tripod foot lifting dolly. It can easily pry up and assist in the walking of the large tripods 1 foot at a time with minimal effort. Now, gather the iron plate, the hit and miss reciprocation engine, a locomotion attachment, a plate clevis or chain, and a simple 6-foot stone chisel to break away the small chunks. Anchor the engine to the ground and assemble all the pieces for cutting. Lay out the first block pattern and start cutting in pairs of incisions 6 to 8 inches apart. Make the first 2 cuts in about a foot or so, then break out the pieces and repeat to the desired depth. Then reorient the giant blade to cut all the required incisions as indicated by the diagram, breaking out the small pieces as you go. Keep the rubble for wall filler later. There is one end that starts the quarry where multiple cuts must be made. These cuts should be made a little deeper to get the leaf spring wedges pounded in more easily. Cradle the block with side straps and apply upward hoisting pressure while driving in the wedges. The block will release itself after tapping in the wedges evenly and uniformly. The sound that they make upon each hammer strike indicates the tension on each wedge. When the block is free, underbelly chains should be placed under for safety when hoisting and rigging. Repeat this process block by block. In this way, one can quarry very straight and clean blocks with a giant blade. The lines are still left in the quarry today, and the interior cuts are almost perfect everywhere. This is the benefit of machinery, precision and production without so much labor. So now that we have quarried standard-sized blocks according to the length of the iron door, we can now move them and sculpt them into artwork. Moving these large masses requires simple knowledge of weights, leverage, and roller surfaces. Roller surfaces are key in all the block manipulation. The old black and white Universal Studios movie clearly shows Ed pulling the blocks along with just an old ground-framed ratcheting come-along. As far as stacking the blocks, one can imagine lifting a stone while it is suspended, dragging another under it, and using it to roll the one above to one across, and so on. Slowly this way one can stack giant rocks and build a structure. The key to Ed's ability to perform so much work at one time and do it at night was because he built a multitasking sculpting machine. This was an old world machine designed before World War I near Germany in the Baltic region. This simple DC machine ran off multiple car batteries tied in electrical parallel. Many of these batteries reside at the top of some of the workstation tripods. Some may have sat in banks inside the wheelhouse. In doing so, many advantages present themselves. Being a practical industrial machine with its own power source like any mine or work camp, the machine provides all the power for everything needed, including pumping water and generally lighting. Basically, every car battery on site was connected together, so a solid rail of DC power could be run anywhere on the compound by means of an aerial grid. This allowed old junk headlights to power the place up anywhere at night. Another significantly distinct advantage to this machine. All the batteries tied in parallel means that only one generator is required to charge all the batteries back up when they are all tied together. And that generator is still on site today. It is bolted to a plank that has a cutout for a reciprocation hit-and-miss engine's oil sump. By charging all the batteries at once, the recip engine driving the generator when it's charging is achieving maximum efficiency possible in that it is fully loaded and not wasting power idling otherwise. Now that you understand there's literally 20 or so car batteries all tied in parallel, now you know of the energy available everywhere on site. Taps to jump start a car, or more so, back charge the grid with a car or truck, can be placed anywhere. Center tapping provides less voltage drop. Very quickly, the system recharges for long-term use, especially to use lights at night easily with no recharge. Now here's how the machine works. A few batteries in the system reside inside the wheelhouse. Some of their current will turn the wheel, which is a giant variable speed rotary switch. There is a unit called a PMH that is actually the DC motor's field stator that magnetically pulses the wheel around in one direction. This in turn makes and breaks an electrical contact. This electrical contact is mounted to a follower that rides on the four-leaf clover cam lobes. This sends a signal from the same battery bank out to all the tripods on a third positive wire. To summarize the machine's totality, when that pulse of battery voltage is sent out on the grid's third wire, it picks up a small relay like that of a car horn. When that small relay pulls in, it makes a larger contact, sending bigger, more local battery current down the tripod and into the actuating solenoid. This solenoid pulls back an iron drive shaft or any other type of iron slug, and then a spring returns the actuator back when the rotary switch drops out again. There can be multiple actuators cutting at the same time to really accomplish a lot in a short time. Most manpower is spent moving the rocks, not cutting or sculpting them. Sweet. So that brings us to the last and most misunderstood part of this mystery, Ed's Sweet 16. All through the years, there is a legend about a girl. I would never attempt to disclaim that. However, I would also never rule out the possibility of multiple parallels. One such parallel could have been and probably was his machine, the old girl. Wire sizing of 16 gauge for the stator and having 16 magnets on the original Model T flywheel stacked 6 high are two coincidental potential correlations. I believe the wheel left at the castle today is the last one he made and was modified from 16 poles to 24 for engineering reasons. These include more torque and better speed control. Now I will describe the trickiest part of this machine. The actual key to making the wheel turn is hanging on the wall at Coral Castle Museum today. It is a homemade 2-pole magnetic proximity relay, or commonly known as a reed switch. This 2-coiled electromagnetic adjustable relay oscillates back and forth on a metal plate, connecting and disconnecting the field stator, thus pulling the spokes around in circles. Timing and voltage control is critical. This relay is also fed from the battery bank and is controlled by a home-wound bottle resistor. Same for the PMH, thus controlling speed. The bottle windings have a metal shorting bar to cut out unwanted resistance, varying the magnetic field of either device. Still, all fed by the same bank of batteries. Now, since the wheel is self-propelled, a man can now go out into the field to operate multiple workstations. 4 of these workstations might include 1. A water pumping station, 2. A horizontal reciprocating crosscut saw driven by a Russell mechanism, 3. A vertical reciprocating scroll saw using the wire roller as a tailstock, and 4th and most famously, a yoke-mounted chipping hammer that pulls a drive shaft into the giant copper coil hanging on the wall at the castle. Many parts are still there, including the coil that fits perfectly into the famous motor housing. The brake drum that held all of that is missing. Now I will list all of the unknowns or non-truthful misnomers and how they really and practically apply to this system, thus putting to rest most of the purgitude, negativity, and human illusionment surrounding what we are and have been. Most of the lore shrouding Coral Castle has arisen due to unknowns and our famous quotes from high-exposure documentaries and hearsay, etc. Here are the new plausible, provable, agreeable knowns condensed in a list. The first one, the wheel purpose, is a battery-operated, DC pulse motor-driven, variable speed rotary switch. 2, the black boxes are there to protect the battery bank, its relay, electrical connections, and the tripod pole ends. 3, free energy. Batteries wired in parallel will run headlights all night long. 4. The purpose for the PMH. The permanent magnet holder is the DC motor's field stator. The wheel is the rotor. 5. The rocks floating. The old black and white movie shows 2 tiers of logs under many, quote, floating blocks. 6. Ed used to say, waiting on his sweet 16. That is cutting the rocks by itself. Sweet. 7. Soon my sweet 16 will come. After he quarried, soon he built his first sculpting machine. 8. The wives' tale of working at night. Large car battery capacity for headlights at night. And he worked at night because it's hot during the day in Florida. 9. Ring bell twice. A moving magnet, a PMH, and a light will light 2 times. Expansion once during the field, and collapsing will light it the second time. 10. The iron door. With a hit and miss recip engine, Ed cut into the earth with the door itself. 11. The iron door drawing. The configuration of the 4 propulsion poles on 2 of each side, the opposing configuration. 12. The wishing pool. This is the configuration of the 4 propulsion poles together in the adjacent configuration. 13. The wheelbarrow. The wheelbarrow is primarily used to encircle, jack, and roll tripod feet 4 to 8 inches or so. 14. The wire straightener. The wire straightener is plausibly the spring-loaded tailstock to Ed's giant scroll saw for wheels and curves. 15. The dented motor housing. This dented motor housing retains the big actuator coil on the wall. 16. The large coil on the wall. The large coil on the wall holds the shaft on the floor with the big nut. 17. The Russell mechanism. The large L frame right-hand corner leaning up in the Coral Castle tool room is used for horizontal cutting. 18. The 2-pole reed relay. This 2-coiled plate relay pilots the PMH, which turns the wheel magnetically. 19. The long 8-gauge coil. This is the actuator coil for the famous yoke in the Ed at Work picture. 20. The small bottle resistor is used to limit overcurrent on the reed relay coils. 21. The large bottle resistor. This is used to change the speed and resistance of the windings using the shorting bar. 22. Sweet 16 was adopted as the name of his machine because the PMH is 16 gauge and the first machines had 16 poles due to the number of magnets on a Model T. 23. Singing to the rocks. The machine provides a steady rhythm to compose and perform songs by. 24. Made by one man. The machine did all the cutting. He did all the physical work on cooler nights. 25. The black on the arm switch and the wheel. This is caused from the arc splatter from the grid pilot circuit. It shows the wheel turned counterclockwise. 26. All of the electrical wire on site. On the roof of the castle and in the tool room, This wire was used for the power grid. There are many possibilities of minor trade techniques that have come and gone, and maybe we will never know the exact details of how Edward Leedskalnin did everything unless we recreate it ourselves. But what has been brought to us with this information should close the mystery and stop the misleading of truth. That's all. The end.